Here is assignment 2.5. So for this assignment, we are practicing the shortcuts or to take the derivative, and we're applying it in different ways. So first of all, this should be a shorter assignment just because the shortcuts just don't take as long. So y equals 2. What's the derivative? And use the correct symbolism. So it's just y equals, and the right symbolism is y prime, and the derivative of 2 is 0. So the derivative of any constant is 0. That's the slope of a horizontal line. 2, f at x equals x squared. What's the derivative using shortcuts? That's the power rule. So 2 times 1 in front, subtract 1 to the exponent, and there it is, 2x. All right, we're just going to keep practicing that way. X cubed, so g at x equals x cubed plus 1. So the derivative of g at x is x cubed plus, the g at x is x cubed plus 1. So the power rule, 3 times 1 in front, subtract 1 to the exponent, and then the derivative of 1 is 0, so it's just 3x squared. This is a good review, right, of what we did a couple lessons ago with the at the beginning of the booklet. So y equals t plus 2. That would be y prime. The derivative of t is 1, so it's just y prime equals 1. Number 5 is f of t equals negative 2t squared, subtract 3t plus 2. Take the derivative of that. So the derivative of f of t is 2 times negative 2. That's negative 4t. And I subtracted 1 from the exponent. For a linear, like negative 3t, it's just negative 3. And the derivative of 2 is 0. So there is a flow to this, as you know, the power rule. And we'll be practicing this so much throughout the year that it just gets easier and easier and easier. It's like adding 2 plus 2. So f at x equals, so we have negative 1/3 x squared, subtract 2/5 x plus 5 over 2. So what's the derivative of that? So we need to know how to handle the frac. 2 times negative 1/3 is negative 2/3. Subtract 1 from the exponent, it's negative 2/3 x. Negative 2/5 x, that's just negative 2/5. And the derivative of 5 over 2 is 0. Done. All right, number 7. Number 7 says find the value of the derivative at a given point and show the steps. So first step is to do the derivative. So that's what I'm going to do. So I'm going to go right to it. Negative 2 times 3 is negative 6, and subtract 1 to the exponent. So it's negative 6x to the negative 3. Then it says plug in. So at that point, all I need is the x coordinate. And the x coordinate there is 1. Now, one of the properties of this that you should always know is that when the base is 1, 1 to any exponent is equal to 1. So this is the same as negative 6 times 1. So again, a good property to know is 1 to any exponent always equals 1, and then 1 times negative 6 is negative 6. 8. Take the derivative of 8. Some of these you can definitely do without me, and you're just checking to see if you did them correctly. Or you can practice with me. So I have x squared subtract 2x. So the derivative of x squared is 2x, and the derivative of negative 2x is negative 2. Then all I need is the x coordinate, which is 2. I plug in 2 and solve, and the derivative there is positive 2. Number 9, take the derivative. That is 3x squared. The derivative of negative 1 is 0. Then I just need the x coordinate, which is positive 1. So when I plug in positive 1, the answer is 3. The last one here, I'll sneak that in right here. Number 10, the derivative there, the derivative of, and make sure you're using that correct symbolism for derivative, that prime. The derivative of 2 is 0. The derivative of negative x cubed is negative 3x squared. Then all I need is the x coordinate, which is positive 2. And that's 4 times negative 3. So the derivative there is negative 12, or the slope of the tangent line at 2, negative 6 is negative 12. All right, I'm going to turn this over. Number 11. And number 11, it says differentiate and then show correct symbolism when you do it. So we start with y equals 1 over x. In order to do the power rule, this needs to be written as a power. So the power that would be written as, it means the same as x to the negative 1. So the derivative then would be negative 1 times 1, so it's negative x in front, subtract 1 from the exponent, and it's negative x to the negative 2. Never feel that you need to write it without a negative exponent. That answer is perfect the way it is. Number 12. Can I write number 12 so that I can do the power rule? So I'm going to go right to it. So we have x squared, and then we have a fraction. So we're going to write that as negative 4x to the negative 2. So x to the negative 2 means the same as x squared in the denominator. Now I can do the power rule. So the derivative of x squared is 2x. And then negative 2 times negative 4, that's positive 8x, and subtract 1 to the exponent. Number 13. Again, my first step is, can I write it in a way to do the power rule? So for number 13, in order to do the power rule, I actually need to expand it. So the first thing I'm going to do is I'm going to go 2x subtract 1 times 2x subtract 1, and then I'm going to expand it. So this is 4x squared minus 2x minus 2x, that's minus 4x, and then plus 1 when I multiply it out. Then when I take the derivative, I get 8x minus 4. So can you do a little bit of algebra before the calculus? Number 14, g at x equals, and again, I'm going to do some algebra. That means I'm going to distribute the x. So x times x squared is x cubed, and x times 1 is x. So now we have no parentheses to worry about. The derivative of this is 3x squared plus 1. Done. Number 15. Again, we want to write it as a power so I can do the power rule. Number 15. So to see this, I first need to see that the square root of x is x to the half. And when x is in the denominator, I'm going to put a 1 there so you can see it. So when I simplify this, the bases are the same and you divide. That means you're subtracting. So when I subtract the exponents, 1/2 take away 1, I get negative 1/2. Then when I take the derivative of that, negative 1/2 times 1, and then subtract 1. Now be careful, that's like negative 1 subtract 2. This is going to be negative 3 over 2. And that's a perfect answer. You don't need to do anything more with that answer than that. Number 16. Again, I'm looking to write it as a power. So the cube root of x is x to the 1/3. The square root of x is 1/2, but that x cubed inside of it makes a 3 in the numerator. So do you have the ability to write it in exponential form? If it's a radical, it's a review. But you should have and need to have this skill to write something exponentially if it's a fraction or if it's a radical. Because now you can do the power rule. Otherwise, you have to do a limit to take the derivative. And you know you don't want to do that unless you're told to. 1 take away 3, that's negative 2 over 3. Again, 3/2 times 1. Again, 3 take away 2, that leaves me with 1/2. So it's a quick technique to subtract 1. And because the technique is subtracting 1, when you have a fractional exponent, that quick little technique is important. 17. I'm going to separate this. I see a monomial in the denominator. Now, a monomial means that there's only a term in the bottom. So when I see this monomial, what I'm going to do is I'm going to separate it. So that t belongs to the first and to the second. So instead of writing it with one fraction over t, I write it with two fractions where both are over t. Then simplify. T squared divided by t is t, and the t's divide out and you have minus 2. So then when you take the derivative, it's just taking the derivative of t subtract 2. The derivative of t is 1, and negative 2 is 0. 18. I need to have the ability to write that exponentially. So to write this exponentially, I see a fraction. So I know the exponent is going to have a negative to it. And then I see a radical, so I see both. So can I write that radical as an exponent? So that radical as the exponent is 2/3. Remember, the radical part is the denominator, and if you have a power inside, that's the numerator. Then I take the derivative of this, so that's negative 2/3. times 1, subtract 1, that's negative 2 subtract 3. So that's where I get negative 5 over 3. That's it. Number 19. Just some algebra to make the calculus easy. So again, what I'm going to do is I'm going to write this with no fraction. Now, that 1/3 I'm going to write in front. So you see 1 over 3, just write 1 over 3. Just the x, I'm going to have a negative 2. That will make it easier if you separate the 1/3 from the x squared. And now do the power rule. Negative 2 times a third, subtract 1, and you have negative 2/3 x to the negative 3. Number 20. In number 20, oh, here's the last one like this. So for this one, we're going to do something similar. But first, do you see the parentheses that make it different? So the parentheses make this 9x squared, because that exponent 2 belongs to the 3, and 3 squared is 9. So I'm going to write this as 1/9 x to the negative 2. Then when I take the derivative, negative 2 times 1/9, that's just negative 2/9. Don't make that complicated. And then subtract 1, and you get negative 3. 21. Now, this is a new part of the lesson that we didn't do before. That is, a derivative can actually have different steps to it, meaning that you can have a first derivative, a second derivative, a third derivative, a fourth derivative. You can go on forever. So when you find the second derivative, you're finding the derivative of the derivative. And if you're finding the third derivative, you're finding the derivative of the derivative of the derivative. So we just have to go one step at a time. So if I see y equals 3x squared, we say the first derivative then is 2 times 3, subtract 1, and then the second derivative, we use 2 tick marks instead of 1, second derivative. I take the derivative of what I just did, and the derivative of 6x is 6, and you just did it. First derivative, second derivative. Number 22. First, I'm going to write it properly. So if I write this properly, I have x squared subtract 4x to the negative 2. The first derivative is 2x. The second derivative, negative times the negative is positive 8, x, and then subtract 1. The second derivative, 22 just says, find the first derivative at 4. So that's as far as I need to go. So then I just need to plug in 4, and then there's my answer. What did I do? I must have been looking somewhere where I shouldn't have. So x squared minus 4 over x squared. Where did I even see that? Did I dream that in my head? Oh my goodness. I was looking at number 12. Let's do this one over again properly. 22 again. That's why you double check. So 22, if I write it properly, the square root of x is x to the 1/2, and it's plus 2. Now the first derivative at 4, you would take the derivative of that. So 1/2 times 1 is 1/2. Subtract 1 from the exponent, and then the derivative of 2 is 0. So that's, the derivative of f at x. Then I need to find the derivative at 4. You take that answer and plug in 4. You don't have to simplify it. If you ever did have to simplify it, the 1/2 means square root. So the square root of 4 is 2. And then the negative means do the reciprocal. So it's 2, but the reciprocal of 2 is 1/2. And then you multiply the tops and bottoms and you get a quarter. All right, 23. I want to find the second derivative at 2. So the first derivative, I'm going to write properly. That's 2 subtract 2t to the negative 1. So the first derivative, the derivative of 2 is 0. A negative times the negative is positive 2. Subtract 1. That's negative 2. Now I need the next derivative. So to find the second derivative, I take the derivative of the first derivative. So now take the derivative again from your answer. So negative 2 times 2, that's negative 4. Subtract 1, that's negative 4t to the negative 3. Then I need to plug in 2. So to that answer, plug in 2, and that's a great answer. Now, if I had to simplify it, 2 to the negative 3 means 2 times 2 times 2, which is 8, but then the negative exponent means you do the reciprocal, so that's negative 4 over 8, or negative a half. But this, for the AP exam, you can leave the answer like that. 24. For 24, I'm going to first expand using some algebra. So x times x is x squared, and x times negative 2 is negative 2x. I want to do the first derivative. That's 2x subtract 2. I want to do the second derivative. The derivative of 2x is 2. The derivative of negative 2 is 0, so that's it. And then for this one, it wouldn't even matter what you substitute in because the derivative, second derivative is always 2. 25. Now, do you see a little 3 there? Sometimes you see 3 tick marks. So they just put down a 3 there. That's what I'm looking for. But sometimes you'll see 1, 2, 3 for that. So if you're looking for the third derivative, first take the first derivative. Now, it already tells you the third derivative is given. So what you're looking for is the fifth derivative. So the fourth derivative then is you take the derivative of what you see. In the derivative of 2x subtract 1, that derivative is 2. And then when you take the fifth derivative, well, the derivative of a constant is 0. So when you take that fifth derivative, add an x value, so that x coordinate's 3, no matter what number you plug in, the answer would always be 0. 26. Here's another symbolism for derivative, d by dx, and you have x cubed plus 5. So that symbol is another symbolism we use for derivative. That's what it means. So can you find the derivative of x cubed plus 5 with respect to x? That's how we read it. So that answer would just be 3x squared. So 3 times 1 in front, subtract 1 to the exponent. The derivative of 5 is 0, and that's it. 27. You're asked to find the second derivative of that. But in order to find the second derivative, we first have to find the first derivative. So this is how the first derivative would look like. So to find that first derivative, the derivative of 3x is 3. The derivative of negative x to the negative 1, that's negative times a negative, that's plus. Subtract 1 from the exponent, and you get 3 plus x to the negative 2. Now, to write the symbolism properly for the second derivative, look at the question again carefully so you get the symbolism that you need to show for that. So it's d with a 2 and then a fraction line and then dx to the 2. So this is the second derivative, still of 3x minus x to the negative 1. But now we can write that down because now we have the first derivative to go from. So the derivative of 3 is 0 and the derivative of x to the negative 2, do the power rule. So that's negative 2 times 1 in front, subtract 1 from the exponent, and you get negative 2x to the negative 3. And that's it. And you don't have to worry about a negative exponent. So you don't have to write that without negative exponents or write it as a fraction. Number 28. Now, these questions have to do with finding the tangent to the graph of 5x, x squared minus 1 at that point. So when you're asked to find the tangent, we're asked to find the equation of the tangent line, which is a linear equation. So let's first start with what we got. So we have a function, f at x equals x squared subtract 1, and we have a point on there, which is 2, 3. So the way I set this up for the tangent line is right away I try to understand there are 3 things I need to know about that line. I need to know the x coordinate. Well, that's given. I need to know the y coordinate. That's also given. And I need to know the slope of that line. Well, that's where calculus comes in. To find the slope of the line, that is what a derivative means. So I'm going to take the derivative of f at x, which is 2 times 1, subtract 1 from the exponent. The derivative of negative 1 is 0. So there you go. And then I need the x coordinate. So to find this slope, you plug in the x coordinate only, which is 2, into the derivative. And now you have what you need. So 2 times 2, of course, is 4. Now here's our answer. So our answer is, what's the equation of the tangent line at that point? So now we're going to write it in HK form to be as simple as possible. So the slope is 4. Our x coordinate is 2. So we're going to change the sign and then keep the sign. And you don't need to write it in mx plus b form or any other form. That is a great form. As long as you know those 3 things and understand the template to plug it into, it's very quick to come up with the equation of a tangent line. 29, let's see what we're given. Tangent to the graph f at x. Now right away I'm going to write this differently. So instead of 2 over x, I'm going to write it as 2x to the negative 1, so that I can do the power rule. Now, in this question, you're given the x coordinate, but you're not given the y coordinate. So to understand what the y coordinate is, you just have to plug in. And when you plug in 1 and solve it, it's just 2 divided by 1, which is 2. The next thing I need to do is find the slope at 1. That will give me the 3 things that I need. Now to find the slope when x equals 1, that's the same as the derivative. So underneath, I'm just going to take the general derivative. That's negative 1 times 2, subtract 1 to the exponent. Now, again, I don't need to simplify this. I'm going to plug in positive 1. Sometimes it's good to remember this. 1 to any exponent is 1. So negative 2 times 1, that's just 1. So that this is my final answer here. Start with the slope. Do I need a 1 in front? No, but it shows you the template. And then it's x subtract 1 plus 2. Could you also see the answer as 1 times x, 1 times negative 1, plus 2. So that means the same as y equals x plus 1. But this is a perfect answer and something great to practice until you remember it. Number 30. Normal. So the word normal means perpendicular. So first of all, let's just start from the beginning. So we're going to write this calculus friendly. So that's 2x to the negative 1. You're told that x equals 1. Y then equals 2. So when you plug in 1 again, oh, this is actually the same question. So all I need to do is take the answer I got. Remember the slope of the line was positive 1. Normal means perpendicular. And for perpendicular, you have to do 2 things. You have to do the reciprocal. Well, the reciprocal of 1 is 1. And you have to do the opposite of that. So it's called the opposite reciprocal for perpendicular slope. So the reciprocal is 1, but it has to be negative 1, that opposite one. So for number 30, then put that together and you get y equals negative 1. Oh, let's go back. What's negative 2 times 1? This answer was negative 2. So this answer here should have said negative 2. Silly me. That's why you keep the video rolling so I can catch my mistake. So negative 2, exit, which makes this one, the perpendicular one, negative positive a half. So what's the reciprocal of negative 2? And the reciprocal would be negative a half, but it's the opposite of that. So negative 2 and positive a half are perpendicular slopes to each other. They meet at 90. So the word normal means perpendicular. So it'd be 1/2 and then the same, x minus 1 plus 2. Good to check your work, right? Number 31. Tangent. So we have y equals x squared subtract 2x plus 3. So I know x is equal to 1. I need to find the y coordinate. So I'm just going to plug 1 into the function. What's the y coordinate when x is 1? So it's 1 take away 2 plus 3. So that y coordinate is positive 2. Now what's the slope? Well, that's the derivative at 1. That's what's going to give me the slope there. So I need to know the derivative of y. That's 2x minus 2. So what happens when I plug 1 in and solve it? The answer is 0. Now, if I put this together, the slope is 0, x minus 1, and then the y coordinate plus 2. Now, 0 times anything would just leave you with y equals 2. That's also a great answer. But both are correct. All right, turn the page. Number 32. Find the x values of all points where the graph of f at x has a slope of 11. So let's break this apart just a little bit. So f at x equals 3x cubed plus 2x minus 2. So what are the x values of all points? So I'm not given an x value. That's what I'm looking for. The slope is given. The slope is 11. So what does that mean? Well, that means the derivative is equal to 11. And I don't know what the x value is. So I want to know what x equals to give me that answer. So step one is take the derivative of what you see. So 3 times 3 is 9. Subtract 1 from the exponent. The derivative of 2x is 2. And then you take that answer and make it equal to 11 and solve it. So I'm going to subtract 2. I'm going to divide by 9. And then when I take the square root, I get two answers, positive and I get a negative 1. I'm not given a domain restriction, so both are correct. So what x values do you have a slope of 11? And I took the derivative, made it equal to 11 and solved it, and realized there are two answers that give you the answer 11. 33. Find the x values again, where the graph of that has a horizontal tangent line. Now, if something's horizontal, that means the slope is equal to 0. So what I'm looking for is to take the derivative of what I'm given. So the derivative of what I'm given, oh, and it's y, so why not write it as y prime? That would be 4x cubed minus 6x, and then the derivative of 2 is 0. And then I'm going to make that equal to 0 and solve it. So to solve this, I'm going to factor out an x squared and a 2. So if I take out a 2 and an x squared, that's the greatest common factor. That leaves me with 2x subtract, why did I say x squared? That doesn't work. So just x. So take out a 2x, that leaves me with 2x squared minus 3 equals 0. So when you factor out the 2x, take each factor now equal to 0 and solve it. So if I take 2x equal to 0, when x equals 0, the slope is 0. If I take 2x squared subtract 3 and I solve it, add 3, divide by 2, and then again, remember you're solving a quadratic. So when you do that, you're going to do the square root. Again, the AP exam doesn't matter if it is rational or not. So you don't have to rationalize the denominator. So it's plus or minus the square root of 3 halves. So you have 0 and then plus or minus the square root of 3 halves. At those x values, the slope is 0. 34. Y equals 1 over x and has a slope of negative a quarter. So find where that's true. So all I'm given is the slope. And notice I'm asked for the point or points where that's true. So I know I need to take the derivative. And that means the same as x to the negative 1. So negative 1 times 1 in front is negative x. Subtract 1 from the exponent, that's negative 2. Next, I'm going to make that equal to a quarter, and it's negative a quarter, and then solve it. So now we have to go back to algebra. So this was calculus friendly, now I need it to be algebra friendly. So to be more algebra friendly, I need to write x to the negative 2 as 1 over x squared. If you look at it carefully, both sides have a negative. They both have a numerator of 1. I can simply take 4 and make it equal to x squared. Take the square root to both sides, and know again you're solving a quadratic, so the answer could be positive or negative 2. So we now have the x coordinate, but it asks us for the points, not just the x coordinate. So we have positive and negative 2. I still need to find the y coordinate. So I need to go back to the beginning, 1 over x, and realize positive 2, if I plug it in, gives me positive a half. And if I plug in negative 2 here, I get negative a half. So positive 2 and 1 half and negative 2 and negative a half. All right, 35. In 35, it says find the AROC of this function. AROC means slope with 2 points. So it's y2 minus y1. So in this case, it's from 4 to 2. Now that is my denominator, 4 and 2. To find the numerator, I plug in 4 and I plug in 2. So that's what I'm looking for. So when I plug in 4, 3 times 4 cubed, and then subtract 4. So in my brain, or looking at the answer key, that's 188. Plug in 2, so that's 3 times 2 cubed, So that's 24 take away 4, that's 20. All divided by 2. Simplify all this, and the average rate of change is 84. 36, what's the instantaneous rate of change? So if I'm looking for the IROC, that's the derivative of that same function. Now, the derivative of f of x of 3x cubed minus 4 is 3 times 3, which is 9x squared. The derivative of negative 4 is 0. Then you substitute in, and the x coordinate that you substitute in is 3. So plug 3 in. 3 squared is 9 times 9. And the instantaneous rate of change there is 81. 37. Find the AROC again. So if I'm going to find the AROC of that, I know 4 and 1 are my denominator. And then that's what I plug into my numerator. 4 and 1, you plug into the function to get your numerator. So if you plug in 4, you get 4 over 6, or 2/3. If I plug in 1, I get 1 over 3. And there's your answer. Now I can write that as 2/3. I know that 2 take away 1 is 1/3 times the reciprocal. So if I put it all together, the average rate of change there is 1/9. For 38, it asks you to find the rate of change at a point. So if you're finding the rate of change at a point, that's the same as finding the IROC. So instantaneous, exactly at that point, what's the rate of change? That's calculus. So I need to take that x squared subtract x, and I'm going to take that and write it as 2 fractions. So that x squared belongs to the x squared and to the x, and then simplify it. Now, when I simplify x over x squared, that's 1 over x, and then I write that not as a fraction, but with a negative exponent. So I do the algebra. Now the calculus should be easier. So the derivative of 1 is 0, and negative times the negative is positive 1, and subtract 1 to the exponent. So that's x to the negative 2. In the question, the x coordinate is positive 1, and again, 1 to any exponent is equal to 1. So the answer is 1. 39. All right, these are actually off the graph. So let's see the graph. It says find the x values. Find the x values where it is not differentiable. So what are we looking for if you can't take the derivative? So first we're looking for, is it continuous or not? Because where there's an asymptotal hole or a jump, no derivative. But we're also looking for, if it's continuous, is there a sharp corner or turn? We're looking for the same thing, that the derivative is not possible. So in 39, where can you not take the derivative? So it's continuous, but at x equals 1, so at x equals 1, what do you notice? And you notice there's a sharp turn. So I want to actually write it this way, that the derivative as x approaches 1 from the left compared to 1 from the right. So at x equals 1, it is not differentiable. So if you think of this, what's the derivative at 1 as you approach, as x approaches 1 from the left? If you take the derivative from the left, you get the answer -1 or +1. If you take the derivative as x is approaching 1 from the right side, you get -1. And I want you to notice the two derivatives don't match exactly at that point. So only at 1. Sometimes you also say there's a sharp corner, and that's the reason why. Number 40. Where can you not take the derivative? Well, look to see where it's not continuous. So at x equals -1, there's an asymptote, that's why. Not continuous. Same thing here. Where else? At x equals 0. So at x equals 0, there's a hole. Not continuous. 41. At 41, at x equals 0, there's a jump. It's not continuous. And that's why there's no derivative there at 0. All right, last questions here, 42 to 48. Where can you not take the derivative of f at x equals x to the 2/3? Now, this is an uncommon graph, but if you see the graph, I think you'd have a better sense of it. So x to the 2/3 is a continuous function. 0, 0 is a point, but it is concave down to the right and concave down to the left. And it kind of looks like a seagull when you drew it when you're a little kid. That's what the graph looks like. And so at x equals 0, there's what's called a cusp. And no, it is not differentiable. Number 43. You could also take the derivative and see it too. Let me do that. If I took the derivative here, it would be 2/3 x subtract 1 from the exponent. See, that negative exponent means it goes in the denominator. So what x value here would make that undefined? So if you plugged in 0 is what would make it undefined, or off the graph you can see there's a cusp. 43. So since it's an equation, we'll just deal with the equation. Here, if you take the derivative of this, 1/3 times 3 is 1, but then subtract 1 from the exponent. That's x to the negative 2/3, or 1 over x to the 2/3. What x coordinate makes it not differentiable? So at x equals 0, again, it's not differentiable because at x equals 0 would be undefined. And again, if you looked at the graph of it, what you'd see is 3 times x to the 1/3. You'd either see a sharp corner or a vertical tangent. In fact, for that one, you'd see a vertical tangent. 44. So for 44, first thing I need to know, is it continuous? So when I plug in 1 on top and 1 on the bottom, it is continuous because they both give you the answer 1. So if I take the derivative of the top piece, that's 6x, the derivative of the bottom is 1. So when I look at where they meet, when I plug 1 in, the derivatives don't match. So if I think of the derivative at 1, when x is less than or equal to 0, that answer is 6. And the derivative at 1, when x is greater than 1, that answer is 1. They are not equal to each other. So this creates a corner or cusp, if you like. It's not differentiable at x equals 1. Because they don't agree. Left side does not agree with right side. 45. Use the limit definition to find the derivative of that. So if I want to find the derivative of that, and we're going to do this efficiently, the limit definition to find it is plug in x plus h, subtract the function, use parentheses, and you just plug in the function without h, and that's all over h. Then we do algebra, so we're going to expand, keep the 2 in front, that's x squared plus 2xh plus h squared minus 5 minus 2x squared plus 5. Now, if I did this correctly with algebra, anything without an h, that's going to simplify. So 2x squared subtract 2x squared. They're gone. 2 times 2 is 4xh, and 2 times h squared. Negative 5 plus 5, and that's what I'm left with. I'm going to factor out an h. That's 4x plus 2h. Divide out the h, and you get 4x plus, these go, plug in 0, and all you get is 4x. And we know that's the answer, 4x, because the derivative at the beginning using the power rule would have been 4x. So we don't want to do the limit definition unless we're told we have to do that. Oh, did I skip a question? I so skipped a question. That's 46. Here's 45, because I skipped 45. So plug in 0 to begin with. Is it continuous? Yes. Take that derivative at 45. And I want you to notice the derivative here. You get 2x, and you get negative 2x. Now the fun part is when you plug in 0, the first derivative also gives you the same answer, 0 and 0. Therefore, it is differentiable for all values. So there's nothing that would make it not differentiable. So we went for a piecewise. Each piece is continuous. We plugged in 0, got the answer, took the derivative and plugged in 0. Same answer, all values of x. It's differentiable. So I already did 46. 47, using the alternate definition to find the derivative at 1. So to find the derivative at 1, it's now the limit as x approaches 1. The numerator is f at x, which is x squared plus 2x. Subtract, plug in 1. 1 plus 2, that's 3. And that's over x minus 1. The limit as x approaches 1, we take the factor of the numerator. That's plus 3 and minus 1. The two numbers that multiply to negative 3 and add to 2. Notice the x subtract 1 divides out. Plug in 1 now, and the derivative at 1 is equal to 4. All right, all that work to get to here. Last one. Mentally, without showing any steps, find that limit. So, last one, number 48. What's the limit as h approaches 0 of x plus h cubed minus x cubed over h? And so, without showing any steps, what is the answer to that? And you have to know this is the limit definition of the derivative of what function. So, in your head, do you recognize that that's the answer for x cubed? So if I said find the derivative of x cubed, this is what it would look like. So the question is, what is the derivative of that, or what does that equal? Same as the derivative of this, which is just 3x squared. So mentally, without any steps, do you recognize that that's the setup to find the derivative of x cubed? And what is the derivative of x cubed? It's 3x squared. Mr. G Math, over and out. I am so proud of you that you're doing your work. I want you to do your work and then watch the video, or watch the video and do the work with me. Go back and see it again to try to make sure that you understand it. Anyways, I'm proud of you, and until next time.